This conference will now be recorded.
Hello friends, welcome to the demo session on data science. So in today's session, we will be discussing about the end-to-end understanding or a practical understanding of data science. So this should give you a very good understanding of how the data is ingested, what are the different tools which are used for data pre-processing, how modeling is done, and how do we do deployment of the models. So this is kind of giving you a full end-to-end overview of how this data processing or data pre-processing or data modeling or deployment is done in the data science world. So without any further ado, let us start the class. Practical understanding of data science. So before starting the class, my name is Sitaram, and I have around 15 years of experience in IT, and out of which around close to 9 to 10 years I'm in the data area. I worked as a big data architect before, and for the past 3.5 4 years I'm working as a data scientist for one of the MNC. I'm also a passionate teacher, so I do trainings as a part-time gig, and I do a lot of training collaborations. For the past 7 years, I'm also training people. I've trained so many people in the space of big data, Hadoop, Python, data science, and so on. And from an educational background, I have a MTech from BITS Pilani, and I'm pursuing my PhD right now from IIIT Hyderabad. So that is a brief about me. So you would be learning about me more while we are doing the course. But for the demo part, I think this should be good enough. Let us get into the demo, understanding how this entire practical data science is working. So the first thing, so if you have any questions, we would like to, I would recommend you guys to use the chat window. There is this chat window option available, so that you could use the chat window option so that it will not hamper the flow of the session. In the end, we will allocate some time for any practical questions you would like to ask. You could open up your mic and then ask at that time. But during the class, I think unless until it is very, very important to the topic, I would recommend please not break in the middle. That will hamper the flow. If you have such kind of questions, I would strongly encourage you to use the chat window so that I can look at the chat window. I can understand what is the question, and then I'll answer the question in the class directly, right? So as if like I am continuing in the class, so there will not be any breakage. I will look at the question and then answer them as and when possible. All right, so that is the basic etiquettes which we need to follow. I hope you are able to hear my voice, and the screen which is saying practical understanding of data science is visible. If you are able to see it and if you are able to hear my voice properly, please give a yes in the chat window, and you could just say ready so that we could start the session. Right, I would encourage people to participate. We would like to have this as an interactive session rather than just boring monotonous. So you guys are able to see the screen, right? And you're able to hear my voice properly, right? Ready? Yes. All right, very good, very good. So let us first understand about, in the earlier years, Imagine you have a retail business. So imagine I have a retail business which is selling some products, and there are users who are kind of selling the products. And once these products are sold, to track like what products are sold, right? For example, I'm selling 1 kg of rice, 2 kgs of wheat, 1 liter of oil, and some 5 kgs of sugar. So imagine I'm selling these products. Now when the sale has happened, in the we need to track that sale, like who has purchased, how many kgs of so and so product was purchased, when was it purchased, what was the amount by which it was purchased. So all those things we need to track, just to make sure that we are planning for the supply and demand kind of a scenario, right? If I know like how much is the demand, then I can plan for the supply. So I can plan for my future. I can say like, okay, because there are like 100 kgs of rice being sold every month, I need to ensure that at least I have 100 kg rice in the next month, so that I will I can plan that accordingly for all those future transactions. So as a retail shop owner, what generally people used to do is, let us create a system which can track our data into some database. So we will put the data into some database. These databases are typically your RDBMSs, relational database management systems, and they are called as ODS. ODS means operational data stores. What are operational data stores? They are the data sources which are capturing the everyday transactions which are happening. Typically, they are RDBMSs. They are in Oracle, they are in MySQL, PostgreSQL, or any kind of databases, DB2, SQL Server. So these are some of the databases which are used for tracking all the transactions which are happening in the front end business systems, the brick and mortar systems. Here I have taken the example of a retail use case, but you can also think about other kind of use cases, banking or manufacturing or healthcare or any other case in that matter. But for simplicity's sake, we have taken the example of retail. So whenever the transactions are happening, to track what transactions have happened, we are trying to store the data into ODSs. Okay, so once the data gets stored in ODSs, what we wanted to do is, if people have the question like, how many kgs of rice got sold in this month. Now there are questions like, how many kgs of rice got sold in this month or whatever. Then we need to run some queries on these ODSs, operational data stores. So people used to run some SQL queries. So there used to be developers who are required to run some queries which will provide us the analytics, which is typically called as descriptive analytics. Descriptive analytics means we are trying to describe what has already happened. So already the sales already happened, already the people have purchased. What we are trying to do is, we are trying to analyze like how many products are purchased, what are the most sold products, and what are the quantities, how much revenue was generated, which products are providing more revenue, which are products are never getting sold, which are providing the least revenue, most selling product, least selling product. So all these things we would like to run by the SQL queries. All right, so this is working fine for many years in the earlier past. So the people were doing transactions, and then they were getting logged, and separately there were SQL queries which are running on the same databases, and which are providing us the query, which are providing us the result. This is very, very good. Then what happened is, because these SQL queries are running on the same tables, for example, you're trying to create some insert transactions, you're trying to create some query transactions, what is happening is, there are kind of bottlenecks to the actual table. So when the business is happening, at the same time there are long running queries which are running. Either they are locking the database or kind of doing some operations where there is this concurrency. When the concurrency is happening, what happens is it slowed down the front end transactions. It means that you're running the queries in the back end. At the same time, there is one front end transaction happening. So in those cases, there is a slowdown in the processing, right? Are you getting it, guys? So there is a slowdown in the processing, and then people thought that, let us not run our SQL queries during our business time. For example, 9 to 5 is the business time. Business, imagine the 9 o'clock in the morning to 5 o'clock in the evening. Imagine it is the business time. So let us not run these queries during the business time. We will run these jobs in the night. So they created something called as nightly jobs. Now, what are these nightly jobs? The nightly jobs are nothing but the same SQL queries, the jobs which are run on the tables, the same SQL queries, but instead of running in the morning during the time of your transactions, they are run in the night. So when they are run in the night, they are not hampering your day-to-day activities. They are run after the business has closed, and they are running in the night. So this worked for many years again. So the nightly jobs got popularity. People started creating jobs after say 8 p.m., 9 p.m., later in the night, midnight, and so on. So such a way, these nightly jobs became popular. But what happened because of the advent of internet and geographical expansion? So because of the internet and geographical expansion, so what is internet? So internet is providing an ability to book these things in irrespective of the business time. So people are um, booking the transactions and all those things, and throughout 24/7. So it is basically the data is getting the transactions are happening 24/7. So it is not limited to the business time. In the earlier years, people used to have only in one region. Say for example, in US time, 9 o'clock to 5 o'clock is the business time. Other time was called as off business time, and that's where your nightly jobs used to run. But because there was adoption of internet, the geographical expansion, that means that it was not limited to one region. The initially the shops were in US region, but later they expanded to say Dubai, or they expanded to Australia, Singapore, maybe one of the European countries, and so on. So once if the US is sleeping, then it is like the daytime for other part of the world. So because of the geographical expansion, then it has shrinked the time where there is a chance to run these nightly jobs. In fact, it has become negligible. So there was no such lean period in sense the period in which I can run my nightly jobs where there is no impact to any of the part of the world. So there was no such time that we could say that okay, this is the time where we can run the jobs because nobody is active. So at any point of time, many people are active. So to solve this problem, what people did is people created something called as data warehousing. You might have heard about data warehousing. The data warehousing concept actually arrived because of this. So in the olden days, people used to run jobs on mainframes and other things. Then they ported the data to the data warehousing. Now, what is data warehousing? Many people, you might have already familiar. I have not taken your understanding like what background you're coming from and all. But basically, data warehousing is a system in which what we are trying to do is we are trying to export our data from the front end tables, the ODSs, and then kind of put it you can do some kind of transformations with respect to combining multiple tables, joining, doing some basic transformations, adding columns, removing columns. So likewise, we do something called as an ETL process. Now, ETL process is extract, transform, and load, and then you're loading into a separate entity. Now, what help this entity would do is, because there is a decoupling between the front-end tables and the data warehousing, there is a decoupling. That means that they are not related now. Of course, they are kind of ODS data is being dumped into data warehouse, but any operations done on data warehousing would not impact the main tables. Are you guys understanding? Yes. So any transactions which are done on data warehousing, right? So it is not impacting your front-end tables. Because it is not impacting the front-end tables, you do not have the problem of the slowdown of the system or anything like that. So this concept is called as decoupling. Decoupling in sense we are trying to decouple the front-end tables and the data warehousing table so that all the jobs can run on data warehousing. So your jobs can run throughout the day on the data warehousing tables and then create required reports, transactions, and all that stuff. Right? Understanding? So this is kind of the solution which was done. And there was a great advantage for the data warehousing that instead of just having the current data, if you look at the ODSs, operational data stores, will only have the current data. As of today, as of now, whatever is the data, that will be available in the transactional tables. But if I want to have some kind of comparison between what happened last year and last month and last week, then we don't have such kind of comparative information. We will not be storing the old historical data. Now, data warehouses, they are capable of storing old historical data. Now, huge volumes of data will be stored. We have ability to store huge volumes of data. We have ability to store historical data, which has provided us a lot of competence in which we can provide this historical analysis, comparative analysis, and all such kind of reportings can be created. So data warehouse comes up with a lot of their advantages. So we could do this ETL process, extract the data. That means that dumping this ODS tables into data warehouse every day. So we'll try to identify a small period where this image dumping can happen. And once the dumping can happen, then the data warehousing is independent and we can run these queries without any problem. Now, one thing which is a little limitation in the data warehousing is that data warehousing is it's only structured information. So data warehousing, it is like any other tables, it is primarily a structured database. So it is primarily structured. What do I mean by structured? It will have rows and columns kind of a data like any other table. It will have few rows, few columns, then it will have a table kind of a structure. Most of the data is expected to be in the structured format. But if the data is in unstructured format, nowadays there is a lot of unstructured data. There's a lot of variety of data which is coming into picture. What if the data is an image? If the data is, let me take another color. So if the data is images, so I'm just trying some image of mountains and lake and water or whatever. So if you have images, or if you have video data, if you have image data, video data, what else? If you have any log information, now what could be the logs? It could be transaction logs, system log, clickstream logs, any of the log information, whichever is happening, that is can be pushed into your centralized storage. Now, if you have other things like maybe server sensor data, if you have maybe like text data, so on and so forth. Are you understanding? Now, if the data is not in the structured format, it can be unstructured data. It can be images, videos, some scan from the servers, log data which is getting captured, textual information, be it commands, documents, and any kind of information. All that information can be put into a centralized storage. Now, can I put it into data warehousing? No, it is not possible because it has certain limitations when we are kind of having unstructured data into picture. If it is like from a table, from some business table, then you can dump that into a data warehousing. But if it is coming in the videos, images, some textual data and all of that, it is not capable of doing that storage. So what happened? People created something called as data lakes. You might have heard about this word, data lakes. What is a data lake? Data lake is something which is kind of providing a storage space where you can store the structured information. Apart from that, you would also have an ability to store the unstructured information. Both structured and unstructured information is capable of being stored into something what we call as a data lake. Now, what could be in the data lake? You could have something like Hadoop storages. You could have cloud-based storages like AWS S3. You could have something like Azure Blob Storage, and Google Cloud Storage, and so on. So here, because of the space constraint, I'm not writing all of them. But what we are seeing here is these data lakes can be created on maybe on standalone distributed systems, the Hadoop distributed file systems, or it can be created in similar kind of file systems available in the cloud providers like AWS S3 or Amazon Azure Block Storage or Google Cloud Storage. So these are all the possible options which are available where we can store the data both from the structured tables as well as from the unstructured sources. Everybody getting here? Can you give an yes if you're understanding so far? Right? Just to reiterate, the businesses are putting their regular data. The data is going into ODSs. To understand what is happening in the regular day-to-day business, they used to run queries, but the queries were hampering the operations of these transactions. So they thought that let us not run these queries in the morning. So let us run after the day, the evening. Then those are called as nightly jobs. But they worked for some years, but after that, because of the internet and the geographical expansion, there was no such time that nightly jobs can run. So that's it. That's the time people created something called as data warehousing. So the data warehousing was capable of not just running these queries, but it is also capable of storing old information, past historical information. So you have much more powerful ability to give more analytical results. Now, that is really good. So people running the data warehouses, and it is even now very much popular. Even if you are seeing that if you want direct descriptive analytics and reporting of your data, people are still working on the data warehousing, right? So am I audible? I think some people are complaining I'm not audible. Am I audible, guys? Okay, thank you. Okay. So what we are understanding is now data warehouse is not capable of managing this unstructured data. So we are now creating another storage kind of containers which are now able to store this data. So this is very good. Everything is proper. Then what we have done is, once this kind of storage is done, then the next step is what we call as exploratory data analysis. So we do something called as exploratory data analysis. Now, what is this exploratory data analysis? EDA, we call it as EDA. This is nothing but whatever data we have stored. Now, this data is in a very raw format. Now, whatever the data we have stored, we have to do some kind of processing so that we can capture the best information out of the data. All right. So when we want to do the capture of the best information out of the data, then we will try to eliminate unwanted information. We will try to do a lot of techniques like we do data pre-processing. We will do like missing value, imputation. We will do something like encoding. We'll do scaling, normalization. So likewise, there are a lot of technique. We do standardization. So there are a lot of techniques which are available. Don't worry about what are these techniques, how do I do these techniques and all. But for now, just we are understanding that if my data, whatever is stored, if the data is in very raw format, then I can't directly give this raw format data to my modeling or algorithms. Why I can't give? Because if I give the entire data to the algorithms, then algorithms will try to find out insights from unwanted information, right? Just for an example, let me take, you are trying to predict what would be the eligibility of a person for loan or not. So this is a bank, some XYZ bank is there, and it is trying to understand whether I can give loans to so and so person or not. So what are the information they are looking for? They're looking for what is the bank balance of the person, what is the salary of the person, age of the person, any liabilities, and a lot of other things, right? So they are looking for a lot of other information which can provide as a clue that whether a person can be provided a loan or not. So based on which you are kind of creating a model which is doing this predictive capabilities. But if you have some other information, when you are taking the customer information, you might have a lot of information. Imagine you are having the email of the customer. Imagine you are having the phone number of the customer. So do you think if you have a fancy phone number, do you think the person will get better loan? Can you type your answer? If I have a fancy phone number like 9848022339 or something like that, right? Or 9848012345, like if this is my phone number, will I get more loan? Yes or not? No, right? So there is no such scope that if you have a fancy phone number, if my name is Chiranjeevi, will I get more phone number, more loan, right? If my name is Bill Gates or whatever, so or whatever this thing, so just looking at my name or my phone number or my some of the details, for example, I have a fancy email address, cooldude@gmail.com. So if I'm having cooldude@gmail.com, will I get my more loan? No. So what we are trying to do is we are trying to identify kind of a identify some data points which are not aiding our analysis. So we might have to remove such kind of data points Because if I don't remove the data points, what happens is your model will try to analyze all the phone numbers, and it is trying to get some pattern, and then trying to analyze like whether this phone number is yielding towards a better result or not, right? So if we are trying to take phone number as a standalone entity, we are not linking it with any of the government entity like an SSN number or an Aadhaar card. We are not trying to link that. We are just taking it as a individual entity. But if you link it with something else, then probably we might get some clues. But for now, what we are thinking is we take the data as a standalone entity and then trying to analyze whether that gives me any clues or not, right? So technically it doesn't give any clue. So what we have to do is we have to perform a lot of these techniques. There are missing value imputations. When the data is provided, the raw data might have some missing values. You can't give this missing value data to your model. You have to fill those missing values and provide a complete information to the modeling so that the modeling can understand the patterns. Similarly, there are techniques like encoding techniques, scaling techniques, normalization techniques, but different types of techniques are there which will transform our raw data and then create in a data which can be consumed by my models. Now, raw information getting converted into consumable information. So what we are trying to do is we are trying to remove the garbage from your data. If you have garbage in your input of your machine learning model, you will get a garbage output. So what we were trying to do is we are trying to remove the required garbage from your data so that you could get better results. So just imagining that we have done all the pre-processing, we have done the cleaning, transformation, and all those techniques. And then I have created a very proper information consumable data that will be fed to something what we call as modeling. So we will feed it to another area which is called as modeling, or I can call as algorithms. So what does these algorithms do? So there are a lot of algorithms in this space. So the modeling is a technique in which it is trying to do predictive analytics behavior. What is this predictive analytics behavior? We are trying to look at the input data. Based on the input data, the parameters and all, we are trying to predict the ability of my model to give out an information. That is what we are calling as predictive analytics or modeling, or you can have a lot of algorithms here. Now I will not write out all the algorithms, but I'm trying to write some of the prime areas. So we have something called as supervised algorithms, again within which we have classification, in which we have regression, we have unsupervised algorithms, within which we have some of the clustering algorithms, market basket analysis, we have something like PCA, third set of reinforcement learning algorithms. Right, so here I'm trying to write a different set of algorithms which are available. So in the modeling, we have supervised algorithms within which we have classification and regression kind of techniques. We have unsupervised algorithms, we have clustering, market basket analysis, and principal component analysis. And then we have reinforcement learning algorithms. Now, I've just noted down these prime areas, but within which, if you see classification, we have a lot of other algorithms like decision tree, k-nearest neighbors, logistic regression, random forest, support vector machines. So we have plenty of algorithms present within the sub areas of these techniques. And what we are trying to do is we are trying to use one of these algorithms to predict the future. We are trying to look at the data and then trying to predict what is going to happen. So in the example of your loan eligibility, so I have a lot of information about the customer. Looking at the information of the customer, I am trying to predict whether we can give the loan to the customer or not. Now that is the first prediction, which is falling under classification use case. Classification talks about we are trying to classify our data in one or the other groups. So one or the other classes. So I'm saying, can I give the loan or not, approved or rejected? That is the classification use case. Whereas if I'm saying that, okay, if the person is approved, how much loan should I give? Should I give 2,35,000, 8,42,000, 10,21,000? So how much loan I should provide to the customer? That is falling under something called as regression use case, right? So there are classification techniques and regression techniques. Likewise, there are a lot of different techniques are available in the algorithms. So during the course, we will be going through all the details of these algorithms. We will see like which type of algorithms are used, for what type of data, what type of algorithms should be used, what is the difference between the algorithms, when to use what algorithm. So all those information we will be discussing during the course. But here what we are understanding is on an overall perspective that we have a lot of these different techniques and these algorithms are present within those techniques. So if I am running this modeling technique, modeling is an iterative process. This is not like one-time activity. It is an iterative process. It runs in the loop. So what we do is we try to change some of the parameters. We try to make the parameters better, and then we try to run for multiple iterations. We run for 5 times, 10 times, 20 times. After we do all these iterations, changing some of the parameters and all of that, then finally we will get a golden model, which can be called as a candidate model, which can be deployed on your servers. Now this iterative process is called as hyperparameter tuning. So hyperparameter tuning is a technique in which we are trying to tune the hyperparameter so that my model is performing better and better. So we are trying to change some of the parameters of my model so that finally my model is performing better and better. Now, once the hyperparameter tuning is done, everything is done, we have an output model. The model is nothing but it is like an executable code. It is an executable code of your analysis, and that executable code can be deployed on some of the cloud services. So just for example, I imagine that you deploy that executable code on a cloud. Imagine this is an AWS cloud. So this executable code you are deploying on the cloud, and then what you can do is you can create it as an API. What is an API? API is nothing but application programming interface. So application programming interface API will have some input and will give some output. It is deployed on an endpoint. So we will use some tools like for example, you'll use some tools like Docker. You'll use some tools like Flask, Streamlit, and there are different kinds of tools by which these models can be deployed. Now, if you see most of the data science courses or many people, they only talk till this point. They say that, okay, I have used so and so algorithm, I got so and so results, and then I'm done. And then you have learned data science. But that is not data science. That is just one piece, one small piece of the equation. As you're seeing, it has a huge connectivity. Modeling is just one piece of the information. It is only one area in which we will be understanding. We need to know like how this model is deployed, how do we do real-time deployment, what are the different possible options available, how do I create a Docker container, how do I use Flask based REST APIs, and how do I create this API so that the API can be consumed by my front-end services. So what could be your front-end services? It could be an application which is developed on Angular or React, or maybe a mobile app, right? So this front-end service, what it will do is it will basically interact with your APIs, and then you could maybe like you could provide some details and then click a button, say like button like apply or something. And when you say apply, you provide all the details, and then you say apply. It will call the API. API will provide results. For example, do you have this kind of connectivity between both of these things? It will take the input and then provide you back the output. That's how the interaction happens. So this kind of interaction is called as real-time inference. Right? So what is the real-time inference? In the real time, you're trying to, the front-end systems are connected with your APIs. APIs are internally calling your models. They are kind of a packaging thing where it will take some inputs, it will have some endpoints, take some inputs, provide some outputs, and then output is like, is shown in the page. Imagine this is the bank side, say like ICICI Bank. You can go to the bank site and it can apply the loan. You will provide all the details and then say apply loan, and then it will come to the API, it will validate your details, and then it will give back the result that approved. So you'll see a next page saying congratulations Sitaram, you are approved for so and so loan, right? So it internally uses these models, and then you try to create this entire API, and so that it can be deployed on your cloud services, and then your front end can call that API and can get the result. This is called as real-time inference. There is something called as the batch inference. Now, real-time inference is like your front-end services are interacting with you, and that's called as a real-time inference. But you can also have a batch inference. So what is a batch inference? A batch inference is nothing but the same API will be there. So you have the same API, but instead of having in the real-time way, you will have in a batch mode. So the batch is, you will have an input file provided in terms of batches, and that will create an output file. So instead of having one customer detail in the real time, the bank clerk might give you like 100 customer informations. So we would get 100 customer informations for 100 people. We are trying to predict what is the eligibility for every person. So person number 1 eligible, person number 2 not eligible, person number 3 eligible, like that. You're trying to go through all the 100 different customers and then trying to predict their eligibility, and then finally you'll create an output file which is having the person information and approval or denial kind of a column. So this is triggered in a batch mode. Now what is the batch mode? You can schedule these jobs. You could say that you will use a tool called as Jenkins or any other kind of a batch processing. So there are different pipeline creations in different cloud providers, but in general we use a tool called as Jenkins, which is helping us to schedule your jobs. So say like every day at say like 9 p.m. in the night, you run this job which takes the entire data and it tries to do the prediction and then create an output file which can be viewed by the clerks or your agents. Are you following this? Right, there is a real-time inference which is like I'm creating a direct API which can be consumed by my front-end services. It could be web development services, it could be mobile services. They are calling me, getting the prediction and then showing it on their app. That's one way. And the second way is the batch inference, where you are not giving one customer information, you are providing bunch of customer information, 100 customers, 1000 customer informations in a file. So that could be a CSV file or a JSON file or any kind of a file. So you're providing that customer information in a file, and that file will be ran in a batch mode. There will be a Jenkins job which will be triggering at say every day at 9 p.m. in the night, and that will run this process and then create an output file. This is the second base approach. There is one more area which has to be considered, which is the data visualization. Data visualization. So data visualization is an area in which you could use tools like Tableau. You could use tools like Power BI, and we could use in-house tools like Seaborn or Matplotlib and so on. So there are different types of tools which will help us to do visual analysis of your data. So picture speaks more than 1,000 words, and that's the reason we are doing entire thing on a picture based representation, so that we can clearly understand right from the starting till the ending. So this speaks more than the 1,000 words. If I'm talking on something like I can roll some slides and all, then you will have a good feeling, but you might not remember all these points. So that's the reason we are doing a handwritten kind of a thing. Of course, you might not like my writing, but I am sure that you will be able to understand the concepts. You are able to link these concepts and get a full end-to-end picture. So in data visualization, what we do is whatever analysis we are doing, instead of we giving an output file, instead of a file, we try to create reports or charts or graphs in terms of pictures. And those pictures will give huge information. If I want to find out how the trend of the market is there, so then based on that, instead of me giving an Excel sheet, we try to show a graph which is depicting the trend of the market. Then any layman can easily understand how this market is, how is it trending, and what are the different pieces of information, how is it looking, and so on. All those things we will be able to understand from the picture itself. Understood? So any questions on this thing? I will be able to give few minutes for any questions technically related to this. I will talk about little bit about the course, how long is it, what are the timings, and all those things. I will talk a little bit, but any question in this area? Are you guys understanding? So will you teach the design of APIs? Yes, we will design APIs. We will do 20+ projects during this course. So while we are doing those projects, we'll be learning how to design APIs, how to call these APIs from the front-end applications. Of course, I might not be creating a mobile app and so on, but we will be interacting with the APIs. We will create Flask-based applications by which I can interact with the APIs. Okay. I will talk about the general questions, but any questions related to this discussion? Is the pace okay, guys? Are you guys able to understand, right? Right, pace is okay, right? So just to quickly recap, we saw like how the data analysis was done, how the data got dumped into the data lakes. There are other possible options which could be dumped. And once we have the raw data, you perform exploratory data analysis that it performs a lot of different techniques. Once the data is cleaned, you will do modeling techniques where you'll use a lot of algorithms. Once the model is created, it is deployed. It can be used in a real-time fashion where directly people will interact, or it can be used in the batch fashion where the batch jobs will be running. We can also use the data for doing data visualization so that outputs can be represented in terms of charts and graphs so that it will be much more meaningful or understandable for your customers. Right? So this is a general about this thing. So I will talk about some of the general information about the course. So the course is roughly 3 months technical course. right? So a prerequisite is any language, any programming language, preferably Python. Now, if you know Python, that is good. But if you don't know Python, it is fine, because we will be covering Python for data science in the course itself. So we will be starting with mathematics for data science. We will be then going to statistics for data science. Then we will be covering Python for data science and all those topics. So, organizers would be providing you a complete syllabus of our topics. You can go through the syllabus. You will understand what are the topics covered, what are the things covered, and so on. So it would be a prerequisite. So if somebody have a question that, sir, I don't know any programming, can I still do the course? Of course you could do, but I would recommend that you need to have some basic understanding of the language. So some of my students, what they do is they start Python, and Python would take around a month or so to complete. And by the time we get into the actual data science work, they will be done with the basic Python. So they could do parallelly, or if they know the language, or if they know any other programming language, C or Java or .NET or anything, then they can brush up the information. So they can brush up some of the basic things like what is function, what is variables, and all that stuff. So they will get a comfortable. But don't worry that if I don't know language, can I do this or not? Yes, you can definitely do. We will have Python for data science, which is covered in the course, so that you would be able to catch up. So once you have this basic prerequisite, it is a daily class, which is from Monday to Friday. So Monday to Friday IST at 7 a.m. to 8 a.m. 7 a.m. to 8 a.m. IST, 1 hour class daily from Monday till Friday. So if you are from other time zone, then you have to adjust accordingly. For example, people in US, then it will be from their Sunday night till Thursday night. All right, from Sunday night till Thursday night will be for US guys, and for other people, I'm giving in the IST time zones. But if you are in the other part of the world, you can accordingly adjust. If you are from Singapore, if you are from Australia, if you are from any other part of the world, you might have a corresponding time zone, right? So for Singapore people, it would be a little ahead. For US people, it will be the prior day night, and so on. But daily 1 hour class will be there, for lasting for generally for 3 months. So what we'll be doing in the course, we would be doing 20 plus projects, and these will be mini projects and plus 2 capstone projects. So you'll be doing 20 plus mini projects. That means that for different algorithms, instead of we learning the algorithm, we will do it the learning based on the project. I have a very strong inclination towards project based learning, because unless until we get into the practicals, we get into the real way of doing, you will not learn. For example, you can't learn swimming by just watching a YouTube video. You just have to jump into the pool, or you just have to jump into the river, and then only you will be able to learn swimming, right? You can't just learn swimming by just staying at the on the bay. You just have to jump into the water, then only you'll be learning swimming. So unless until you do projects, you learn, go to a lot of YouTube videos, you do a lot of things, you learn to a lot of theoretical things, you'll have a feel good feeling. But unless until you get that practical exposure, right, without doing the projects, you will not be able to learn, right? So that is one important thing I would say. And people will have questions like, do I need to do some certifications? There are some external certifications related to AWS or Azure or There are other certifications by IBM and say TCS. So there are different certifications which are provided for data science. So, but that is once you have completed the course, you will be able to do these certifications, and you'll be able to provide that. So regarding the completion of the course, so once you complete the course, we would also be helping you for your interviews. We will help you in your resume preparation, in mock interviews and other stuff, right? So regarding the placements and all, I would recommend to talk to the career IT folks. You would be able to interact with the organizers. I might not be able to talk on the placements right away, but from my side, I will be able to provide you all the interview related questions. How do you tackle the interviews depending upon your prior expertise? Where do you stand? Because interviews are much more specific to the person. For example, you are a 15-year experience or a 10-year experience guy, or a 5-year experience girl. So depending upon your experience, you might have to tackle it differently. There are different opportunities, different levels of expertise is required. So based on your experience, you have to do it. So it is a one-on-one kind of an interaction. It is case on case basis, right? It is not generic for everybody. So we will provide all the interview questions, which is generic for everybody, but the interview preparation requires a one-on-one approach. Right? So if you are from a different background, if you don't have any experience as a data engineer, so will the industry accept? So there are entry-level roles which are called as data analyst, and which would require an entry-level positions. But what I would recommend is you have to do the full due diligence. You do a lot of projects. You can provide your exposure as a technical person, then you will be able to get it. So the answer is not straightforward. Yes, I will not entice you. I will not say that, okay, do this course and then you will get salary in flying colors. No, that is not going to happen. What I'm trying to provide you is, this provides a lot of open opportunities. What we need to do is, if you have the real capabilities, if you have the technical expertise, for that you have to do a self-assessment of yourself, and then see like how much you know, how much you can learn, and what you can do, and all that stuff, and then you have to take the pledge, right? So I'm not here to do the selling. I'm trying to give you a real picture that unless until you do the practice, unless until you have the expertise, no company is going to offer us any job. So we need to have that expertise, we need to build that expertise, and I'm here to provide you that expertise so that you can build that expertise and you will be able to uh, get the necessary jobs. All right. Any questions? Did you get the clarity? Any more questions if you have?
Sitaram, this is Anji Reddy.
Yeah, Anji.
Actually, coming from the background of chemistry, I completed my MSc chemistry from 2008.
Mm-hmm.
Actually, I'm working in pharma industry.
Okay.
I want to come in the IT field. It is suitable for me that this is a data science.
Yeah, so for example, as I know, a lot of pharma companies, especially Dr. Reddy Labs, and I'm talking from India. So of course,
Mm,
in other parts of the world also there are jobs. But
mm,
Dr. Reddy Labs, Novartis, Sanofi, there is Laurus Labs. There are some
mm,
companies which are kind of offering specially for such kind of roles. They require data
mm,
analyst, data scientist. You could
mm,
go into Naukri, or you could go into LinkedIn and then search these companies. You would see that there
mm,
are a lot of openings in the space of data scientist. They require junior data scientists, senior data scientists, data analysts. Different kinds of roles are there, which has expertise in this special field. So you might need to have special expertise in the chemical area or pharmaceutical area, in such kind of areas. And understanding these data science will be a plus for you. There are a lot of opportunities from Dr. Reddy Labs. So I'm talking from Hyderabad. So I live in Hyderabad. So there are a lot of opportunities in that space, and there are a lot of pharma companies within the vicinity of this thing. So I know there are openings in Sanofi. I know there are openings in Dr. Reddy Labs, and there is one more. Novartis is a company which is providing similar kind of expertise. So you have to identify those areas, and then you have to pitch to that. Get an entry level position, and then slowly go to a higher level. But your previous expertise have to be used in such a way. For example, if somebody is already from a banking background, they want to get into data science, they have to first look for the jobs which are in those areas. Similarly, for your case, you have to look for the jobs in those areas, and then you have to slowly pitch into that. So instead of me talking about your job roles and all, I would recommend you to look at these portals, right?
Working in a pharma company as a quality control. That I had a 9 years. Hello.
Yeah.
Clear,
Go
not
ahead.
a voice. Hello.
Your
Yes,
voice
yes.
is breaking a little bit.
I had a 9 years experience in quality control department. Are you clear now? Are you audible?
Yeah, it's audible.
Hello.
Yeah, it's audible, but it is breaking a little bit. Yeah, continue.
Yes, I'm working in a pharma industry just as a in quality control department. I have 9 years experience. I'm working in MSN laboratories, and I have 9 years experience in quality control. Is it? I think is it? How much time? How much time you take to learn this course? I mean,
So
the
this
duration of
course
the
is,
time.
yeah, duration, as I said, 3 months, but you need to have at least 3 to 6 months related expertise, right? So to land into a job. So I'm not going to give you like a very lucrative answer that within 1 month you will become a data scientist. That is not going to happen. If somebody is promising you that within a month you will be able to change and then do it, they are giving you all false promises. What I want to so this is an answer to everybody, it's not specific for you. What I want to really I want you guys to do is analyze your current working expertise, identify, go into your job portals, it could be here or any part of the world, look at what are the opportunities they are offering, what skills they are requiring, and then we will target exactly those skills so that you can land into those jobs, right? So we have to do that we have to do that analysis. If you don't do, then it will be much more generic, and then we will be learning the course but we are not landing in the job, and that is not our motto. We have to do the switch, means we have to do the switch, and we have to identify what are the areas. I'm just giving you an example because
Sorry to interrupt.
yeah,
Sitaram garu, sorry to interrupt you only. Hello everyone, this is Lakshmi from Career IT. Important info from our end. Regular sessions will be starting from tomorrow onwards. Timings are from 7 to 8 a.m. IST. So you can reach us on the numbers for more details. Thank you. I have provided our contact details in chat. Please check it and contact us for other details. Thank you.
Madam, please put the message again so that people who have missed the message can see it again. Please put the message again.
Hello, sir.
Yeah.
Yes,
So I
sir.
hope the answer.
Good morning. I am Manikumar.
Yeah, Mani.
Sir, thank you for the wonderful sharing your experience here. So I am BTech fresher. I am passed out 2020 from mechanical background. So I have a basic knowledge on Python programming. Present, I am looking for my career opportunity, which is best to fit for me. So my friend suggest to that the career IT as a data science is the best one. So for that way, I am attending here right now. So is it possible to get any zero experience in data science field? I have a zero IT experience right now. So is it the industry or company accepted with the zero experience as a
See, directly roles they will not accept. You will have opportunity like data analyst. But what I recommend people with fresher level expertise, if you don't have a very solid, engineering background, if you are from a different background and switching into the IT world, what I would
yeah,
recommend is identify internships. Okay, you don't waste time. We have to learn the
yeah,
techniques. So, you might be
yeah,
learning data science from here, but we need to identify internships. There are a lot of companies who are ready to give internships. So whether it is
okay,
paid internship or free internship doesn't matter. So whether they pay you or whether it is you are working for free, it doesn't matter. But you have to have working expertise. So first and
okay,
foremost, I will be targeting is what are the companies, where are the companies, where the internship opportunities are provided. While I am learning the course, I would be opting for those internships and then offering them saying that, sir, I will work you for free for 3 months or whatever. I know these technologies. I know how to work on that. Please provide me the internship opportunity. So that is a way to target. First, once you
okay,
get the internship, then once with that internship experience, you can get into smaller projects or maybe target for a bigger companies. But
okay.
what I'm going to
Uh,
say is, this until you have practice, right? You shouldn't
yeah,
waste even 1 day time. You are very targeted. I have to plan for my learning and plan for my internship. Once I have this expertise, then I will have ability to land into the jobs. Once you get the first job, then it is very easy to switch companies or expand your horizons and do things. But for initial entry, because the entry is difficult, either your company will provide, or either your college will provide, or you have to search for yourself. The best approach is internships for you.
okay. Sir, one more thing. Can I search for internship after completion of 3 months entire programming, or else can I parallelly searching further?
Yeah, we have to parallelly do it. Don't wait for 3 months. After 3 months, you start searching. Then it will take 1 month for getting internship.
A couple of
So
months.
this is
Yeah.
all waste. As you are
Okay.
doing, once you get comfort, say like 1 month, 1.5 months, 2 months, that is based on your comfort. See, when you go
Okay.
into internship, you have to work. It is not like you're just going and time pass watching movies and coming out, right? So you have to work. For that working, you have to assess yourself. That comfort level, whenever you get, after 1 month, 2 months, 3 months, whatever, once you get that comfort level, then you have to pitch it. I would recommend start it well in advance, and
Okay.
then you will have, see, nobody is going to open the door and then offer you internships, right? So you have to
Yes,
try,
sir.
you have to spend some time. It might take 1 month, 2 months, but you have to start well in advance so that you get it.
Okay.
And this is for
Okay.
everybody, not just talking for him, but anybody who is kind of in the fresher kind of a role. This is an approach we need to follow. If you are an experienced person, the approach we need to follow is to expand your social horizon, expand your LinkedIn profile, LinkedIn expertise, put some posts, that way you will be noticeable, and then people will notice you, and then you could do it, get better opportunities.
Okay, sir. Thank you. Thank you for the information.
So for the topics, I would recommend, I think there will be a curriculum which will be circulated to you. If you did not get the curriculum, please talk to the Career IT folks. They will be able to provide you the curriculum. Curriculum has all the topics, right from everyday topics. We would have all that information, and it will also cover the 20 plus projects, whatever we are discussing. All right. Any other questions, guys? All right. So thank you very much, and I hope you have loved the session. You got some information from whatever we have discussed for the past 1 hour. You enjoyed the session today. You please join tomorrow's class. At least join few classes so that you'll understand how things would be working, and based on that you could take it forward. All right. Have a nice weekend and take care. We'll meet you tomorrow. Bye bye.